All right, you guys, let's look at the distance formula. Again, I have plotted 2 points already for you. I've recorded the points here. If we wanted to find the distance between those two, so if we were looking for I want to know the distance, I would just put the 2 endpoints. I wouldn't put the segment symbol above. If I'm looking for the distance, this is what it would look like if they asked for that. Well, we can't just count a diagonal distance. It doesn't work that simply. There is a complicated distance formula. I don't want you to be without it, but you can find the distance by taking the square root of the difference of the x's squared plus the difference of the y's squared. It's kind of a complicated looking formula where they would find you would get one of your x's here, here's your other x, here's one of your y's, and here's your other y. And if you plug those values in, you can find the distance formula that way. I'd like to give you a slightly different way of looking at this. We can't count diagonally, but I can count horizontally and vertically pretty simply. If I count horizontally and vertically, I know this vertical distance is 3, and this horizontal distance is 1, 2, 3, 4, 5, 6. I have a horizontal distance of 7. And I was able to just count that off if I'm on the graph. So if I know those 2 measurements, I happen to also be looking at a triangle here. A lot of you have been exposed to what's called the Pythagorean theorem. And that's the idea that a squared plus b squared must equal c squared. C's got to be the longest side. It happens to be the side we're looking for in this problem. But since I was able to count the horizontal movement there, I can plug that in for either A or B. And I can put the vertical movement in for whichever one I didn't use before. So 7 squared plus 3 squared, I want to find what makes c squared there. So right here, I got 7 squared, which happens to be 49. 3 squared is 9. And I still got c squared on the right side. 49 plus 9 makes 58. Well, this measurement certainly isn't 58 because that's what c squared is. I put 3 in for B. I put 7 in for A. I want to find C. I don't want C squared. So the only way to get rid of a square is to use the opposite operation. I have to square root both sides. Now the square root of 58, it's not a simple answer. All right, if you plug it into a calculator, if I square root 58, I'm going to get something in between 7 or 8. But that would mean I'd have to round. So I can actually just leave my answer as the square root of 58. That's the distance that I was looking for. And if you ask me, this process is a little bit easier if you turn it into a right triangle. All right, and just realize this measurement A was found. That's just the difference between the x's. That's what this would have found. This finds us that horizontal measurement. The vertical measurement, the difference of the y is right there. So both these processes are doing the same. If you look at it this way, you just get to count each measurement. Here you got to do a little bit more math. But both would have gotten you to the same solution. All right, so this is the distance formula, but I highly recommend that look at it as a right triangle. Then you can do the Pythagorean theorem in a slightly easier format. Good luck.